Hello everyone. So let's solve today's problem. Find kth element of spiral matrix. And in this problem, we have been given a matrix of n cross m rows, and our task is to find the kth element, which can be obtained by traversing the matrix spirally. All right. So for example, let us look at the first test case in which we have been given the elements like this. And if you don't know what spiral traversal is, let me tell you first. Spiral traversal simply means traversing the matrix like this, then 4 to 8, then 8 to 12, then 12 to 16, then 16 to 15, 15 to 14, and so on, like this. And after 5, we will go to 6 and then to 7 and then to 8, like this. So what we'll be doing is, as you can see, as you can observe, first we are going from left to right. So let us take the left pointer first and right pointer. So we'll go first from left to right. Then we are going from top to bottom, right? So let us take a top variable here, or you can say the pointer, and bottom pointer here. So we'll go from top to bottom. Then we will go from right to left. According to the test case, we will go from right to left and again from bottom to top. Right. And we have to do this process again and again. So we'll do it in loop. As you can see, this is one iteration. Similarly, this is the second iteration. So we will do these things in a loop. All right. So let us understand it through code because it would be difficult to understand through the diagram. So I will explain it step by step. So first take the variables. So where the right would be pointing on. So if you see, these are rows, right? These are rows, and right is moving along the column, right? Right is moving along the column. So if you see 0, 1, 2, 3. So if the row length of the row is n, suppose if length of the row is n, then right is standing upon the n minus 1th column. So it will be n minus 1, and the 0 bottom is n minus 1. So since bottom is here, then bottom will move here. So as you can see, if the bottom was standing at the mth column, so it will have the value m minus 1. So let us now traverse from left to right first. So while traversing from left to right, let us discuss what is constant and what is changing. So while traversing from left to right, what is constant is we have the this row as constant, right? So our top is constant and our left is changing. So our row is constant and column is changing. So it will be ARR of top, comma, the column, right? All right. Yes. So, and then top plus left. So after left to right traversal, our top will point upon here. Otherwise, we will have duplicate elements in our vector. So I'm not gonna write again and again. Let me just copy paste it. Right. So first from left to right, then from top to bottom. And while traversing top to bottom, we have the column constant while traversing from top to bottom, right? So our column is constant and row is changing. So row is nothing but row is changing, which means row will be I. The column would be right. Right will be decremented. Now we'll traverse from right to left. So in this case, again, our column is changing. So our column is changing, right? So our the row would be the bottom, right? The bottom. And now at last we'll move from bottom to top. And while traversing bottom to top, we have the column same and row is changing. So row will be I and column would be nothing but left. And we have to repeat this cycle till our left is less than right and top is less than bottom. Now let's handle the edge case. When we have a single row, suppose we have, for example, 1, 2, and 3. So in that case, top and bottom is standing at the same same row or column. The row and column are same, right? Bottom, suppose B, they are standing at the same place, and after the first iteration, our top gets incremented. So our top moves below the bottom. And when this condition is met, when we traverse from right to left, again our bottom is decremented. So this is wrong because our top has already incre incremented by in have gone below the bottom, right? So there are no elements. We will get invalid result. So let us handle this case. Similarly, for the very last element, we won't be incrementing our left because we have already decremented the right. So there are no elements before, which means after this iteration, we might have the condition when our left has increased the right. So let's check. So let's compile and run. Right, let's submit. Okay, we have some error. Bottom decremented left, then top is incremented. We are traversing correctly, I guess. The only thing here is our right might be moving from column, which means right might be standing at m minus 1. So now let's submit. All right, thank you.